Hello and welcome to this Tungsten Replicator Masterclass training session where we take a look at monitoring and troubleshooting of the replicator. My name is Chris Parker, VP of Customer Success here at Continuant. So in this short session we'll take a look at how to monitor and diagnose some common issues that arise with the replicator, including handling triggers, reviewing the log files and how to recover from failures. There are a number of issues that can occur with replication, and having the tools available to diagnose them will help you build confidence with the replicator and enable you to diagnose and resolve issues quickly and easily. Some of the most common issues we encounter in support can often be resolved without our help if the knowledge and understanding the error message is there. So we encounter many issues that crop up due to lack of monitoring and alerts, and this is probably the top reason for many systems failing due to disk capacity issues or database crashes. Checking the status output will often tell you what is wrong, and even if that's not clear, then reviewing the log files will certainly give you more clarity. Simple checks on the operating system and also on MySQL itself can also help. Many customers experience MySQL issues, but the first symptom they see is that the replicator has stopped and assume the replicator is at fault. So always carry out a full end-to-end check, ensuring all components are working as expected. Another common issue we encounter is often down to human error, ranging from manually deleting THL to not following best practices and writing mistakenly to a replica node. We try and provide as much information on errors as we can, but sometimes issues do occur that can even baffle us. But ultimately, the more triage you can do yourself, the faster our help can be if you do need to contact us. Triggers are something that can cause real headaches in any MySQL to MySQL replication topology, and that includes Tungsten. The issue comes down to how triggers interact with MySQL's binary log information. Depending on whether your replication is using row-based or mixed-based binlog format, and whether the trigger itself is defined as deterministic or non-deterministic, the behavior can differ quite a lot. In some cases, the trigger might execute correctly on the primary, but not on a replica, or it could even cause duplicated or missing data events when applied downstream. The best practice here is simple. Avoid using triggers if you can. If you can't avoid them, for example they're embedded into application logic, then make sure they're written intelligently so they only fire on the primary host, not on the secondaries or replicas. This prevents unintended side effects in replicated environments. There's a detailed explanation, including specific examples of what goes wrong and how to handle it in our documentation, so definitely take the time to read. The link is shown here on the slide. A symlink to the latest log files for the replicator can be found in Continuant service logs, and these logs have the potential to grow, so it is recommended that you configure logrotate to manage them. The replicator dump command can be very useful if you feel the replicator isn't working. It will output a complete memory dump of the Java process into the log file. Our support team will find this useful and be able to understand the issue better. By default, this is issued when you create a diag file as well. Recovering from failures will depend on the issue at hand. Typically, if the replicator goes offline, it will stay offline, even if the issue is a momentary transient issue. Therefore, it's a good idea to enable the auto recovery options. There are 3 options which you can add to your INI file. There's the auto recovery max attempts. This tells the replicator how many times to attempt to bring the replicator online for. After this number of tries has been exhausted, then the replicator will remain in the offline state. Setting this value to 0 or not supplying it at all disables the auto recovery options. Auto recovery delay interval tells the replicator how long in seconds to wait between retries. Auto recovery reset interval tells the replicator how long in seconds to wait after the replicator is back online before it resets the max attempts counter. Always try to review the logs. The error is due to a SQL issue, such as a failure to update a row. The status output may be truncated and not show the full error, but this will always be displayed in the log file. Sometimes restarting the replicator is all that is needed, especially if the replicator has suffered an out-of-memory issue or if there was an issue with MySQL and we have simply lost the connection. If a statement issue occurs, is skipping it safe? Only you will know that as the guardians of your own databases. Sometimes skipping is fine, sometimes not. This will all depend on your own business logic and rules. If the database has crashed, has the database become corrupted, or have you lost the binary logs? If the binary logs are lost and the replicator has not yet extracted the events from them, then unfortunately there is nothing we can do to recreate those events. In situations like that, you may well need to reset and reprovision the data. If THL files are lost but you still have the binary logs, then we can recreate them and hopefully recover the system. We supply a number of scripts that generate Nagios style outputs, and these are located in the path shown here on the slide. They only check the local host on which they are run, but they can be used as a quick check. The output, although is Nagios compatible, you can write your own scripts to wrap around this and use that data to feed into any system. We've also got the full API available from version 7 onwards, and with this you could also easily write your own scripts to suit. We also provide Prometheus metrics, which are enabled, so you can hook into the exporters for Prometheus. Let's have a little demo of some of the items I've discussed here on debugging and trying to find issues. Okay, so what we have here is the extractor and the applier. Both my replicators are running here. And if I just look at trepsvc.log status, we can see that both replicators are online, everything's looking good. Auto recovery is disabled at the moment. Obviously, I'll show you how to enable that shortly. But first thing, log files, opt continuance service logs. As I mentioned in the slides, these are symlinks. So the trepsvc log file here is the replicator log, and its actual location is there. So if you need to set up logrotate, you would set that up to that directory. But service logs there is the way you can just quickly get to that log file. And it's a useful log file to monitor, keep an eye on, and check. So what I'm going to do now is I'm going to try and force a bit of a failure in MySQL. So first of all, I'm going to pretend I'm an operator, and I need to make a change to the database. I'm going to go to the HR table, select star from regions, and I'll go right. I've just been asked to insert a new region. So insert into regions, and I'm going to put in here 5, and I'm going to put my new region. Great, I've put that data in. And then I suddenly realized, I actually made a mistake there. I've put that data into the replica. So now I have an issue in that my replica is further ahead than my primary node. So if I use HR over here, and rather than deleting the row over here and reinserting it in the primary, I just decide to go and reinsert it in the primary. So I'll go insert into regions, values 5, my new region, insert the row, and I don't think anything of it. I think great, my data's in sync now, everything's the same. But then I get some warnings from our monitoring system that says your database replicator is in an error state. So the first thing I'm going to do is, obviously, I'm going to come to my node where the error has occurred and have a look at the replicator status. And sure enough, what I see here is we've got a constraint violation because we're trying to insert a row into the regions table, and that row already exists. The value is 5, and this is the text here. Now, in this case, the error message is relatively short, so we're showing the full message in the trepsvc status output. But sometimes if the error is quite large, or if it's a cascading error of sorts, we may not see the full error message here. It would be truncated. So in that case, you would need to go to the replicator log file, go down to the bottom, because that'll be where the error is. And in here, you can see a lot more information. So here we have the failing statement, we have the detail, and then we have a full kind of error stack. In our case, all we need to know is this top bit, it's a constraint violation. So what can we do? We've got two options. We can either accept that, in this case, we know it was our mistake, so we could say, well, let's just tell the replicator to skip it. We don't want the replicator to apply it, the data already exists, so let's just skip that transaction. But if this was someone else that was looking at this and didn't quite know what had happened, they could look at this and go, well, actually, I'm not really sure. So first of all, you would want to check the sequence number. So in the status output, it tells you the sequence number of the failing statement. In this case, it's 228. So let's have a look at THL, and let's have a look at what the full THL is, because we don't know if this is a transaction of lots of inserts. There could be 5 inserts, a couple of updates, and a couple of deletes, all wrapped up in a transaction. And this is failing because of one of those inserts. So if we were to skip that, we would actually skip all of the other statements in that transaction, which might actually apply successfully. And if we were to do that, we skip all of those, and then we've got a bigger problem on our hands. So first of all, look at the THL, see what the full content of the THL is doing before you do a skip. And if I just output here, in my case, I can see that sequence number 228 is just this single insert statement. So I can make a more informed decision now of, do I skip or do I fix the data on the destination? So I can see that this is the row. So let's have a look at the data again. We can now say, well, let's go on to both hosts and let's look at this data and make a decision. Oh, use HR. If I can type the table name. Okay, so we can see here now, actually on the source, this is what we've got. On the target, this is what we've got. And you can see there's a slight difference in the region name. The text here is a little bit different. So actually, what do I want to do? Do I want to keep that where I've got differences? But then that could cause problems elsewhere. No, actually you want the data to be exact. So what we can say is, right, well in this case, I'm actually going to delete the row on the replica. Delete from regions where region ID equals 5. And then let the replicator reapply it. So delete from regions, region ID equals 5, the row's gone, come back out here, and I can simply tell the replicator to go online. The replicator will retry that statement, and we are in sync. So now they both match. In terms of if you wanted to skip, how do we do that? Well, let me just do, let's create another error. So this time someone has created a database on the replica and then goes to the primary and creates that database. This time the database is the same name. We don't care about deleting the database and re-adding it, but let's have a look at the trepsvc.log status output. Here we go, we've got statement failed on slave but succeeded on master, create database. So this time, this error message doesn't really tell us a lot. We know that it failed to apply it on the replica, but it was okay on the master, but we don't know why. So here we could look at the replicator log file and look a little bit more at the error. We can see it failed, but we don't know why. Here we go, we've got, let's follow the stack down, statement failed, caused by, can't create database, Chris, database exists. Okay, so the database already exists. So we've been able to dig into the log files to get a little bit more detail in this particular instance. So here we can say, well, actually, we can check the THL. We can run that THL command again, but this time it's sequence number 229. And we can see from this that it was literally just the create database. We can just skip this. We don't need to worry about reapplying or letting the replicator reapply it. So here we can do a trepsvc.log online, and we can do skip seek no, and then put that sequence number in 229. Okay, and then we can do trepsvc.log status, and we can see the replicator is online and everything's running, and we know our database is now in sync. So that's a very simple way of showing you how to check those things out. So the next thing is, let's enable auto recovery. So for this, we open up our INI file, and in here we need to add those auto recovery properties. So let's add auto recovery max attempts, and we'll set that to 5. So let's say retry 5 times to bring it online. If after 5 retries we're still in error state, then the replicator stays in that error state. We'll say the auto recovery delay interval, and we're going to set this to 5 seconds. So the value is 5 followed by an S for seconds, and that will retry every 5 seconds. Auto recovery reset interval, and we'll set this to 30 seconds. So if we go into an error state, we wait for 5 seconds and then we'll retry. Wait for 5 seconds and retry. But we'll only retry if it goes into the offline error. If on, say, the 4th attempt, the replicator stays in an online state, and it stays in an online state for 30 seconds or more, then this max attempt counter gets reset, so that next time another error occurs, it starts counting for 5 retries again, so we don't automatically hit that maximum straight away. And that's simply added in, and then all we do is a TPM update and let those changes apply. Now, whilst those changes apply, you may be thinking, well, how did my operator manage to insert data into a replica? If it's a replica, it should be in read-only mode. In my case, I was using a user with root privileges, and as you know, root privileges can still write to a node even in read-only mode. So it's also a good practice to make sure that if you're asking people to make data changes, they're not using high-privileged users that can accidentally make those changes to read-only nodes. It's a good check to put into your security policies. So my TPM update has completed. Just a bit of a sidetrack there. And let's just go to trepsvc.log status. And we can see now auto recovery is enabled. auto recovery total 0. So far we've had 0 attempts to auto recover. So let's just create that error again. So tpm MySQL, and let's create a database here, and then we'll call this demo db, and then we'll do the same over here. Create database demo db. So we know that's going to start failing. So let's have a look at trepsvc.log status. And we can see we're in an offline error state, but we haven't got the error message yet. But we can also see recovery totals is incrementing. And if we keep looking at this, we can see it's gone up to 4 now. And eventually when that auto recovery total hits 5, which is our maximum attempts, we then end up in that failed error state, and it will stay in that error state, and we'll actually get the message there. And that will stay like that now. It won't keep retrying. And what will happen is we can go into MySQL, and we'll fix that. So we'll actually say drop database demo db. The replicator is not going to automatically come online and start again now because it's already reached that max attempts, and it will still be in that error state. But we can say trepsvc.log online, and then we can look at the status. You can see we're online. Auto recovery total is still sat there at 5, but if we wait for 30 seconds, that will eventually go back down and reset to 0, which is what our reset interval was. Obviously, I'm not going to sit here in silence for 30 seconds, but it gives you an idea of how property works. And that's the end of this particular training session. I hope you found those small tips and tricks useful. As I said, it is really important to do as much diagnosis as you can before contacting support, because a lot of the times it could be a very simple error that you may be able to fix yourself and be online much quicker than waiting. But what we've covered today, so we've reviewed those common issues, what can cause outages. We looked at triggers, log files, and then we looked at some failures, skipping transactions. And then finally, I covered the scripts for monitoring and where you can find them. We do have sessions on the API. I mentioned the API in that last slide. It's useful if you want to understand the API a lot more, then do go and listen to that API training session. But from me, for now, that is all. Thank you for listening, and I hope to speak to you again soon on the next session. Thank you and goodbye.